Hello everyone, I'm Zheng Gao from Queen Mary University of London. Today, I'm going to present our work Diffusion-Based Makeup Transfer with Facial Region-Aware Makeup Features. In this work, we focus on two tasks. The first task is global makeup transfer that copies the makeup style of the reference image into the source identity image. The second task is region-specific makeup transfer that combines the original makeup styles of several different reference images into one image. For example, in this figure here, in the first row, we show the global makeup transfer. The second row, we show region-specific makeup transfer by combining the skin makeup, eyes makeup, mouth makeup into one image here. So prior works in this kind of research mainly used a foundation model that is pre-trained on natural images as makeup style encoder, and this foundation model is generally optimized for general tasks, which might not be the optimal choice for our makeup transfer task. Also, these methods usually have limited regional controllability for region-specific makeup transfer. So in our work, unlike prior works, we propose to learn a better makeup style encoder, a fine-tuning clip with self-surprise and image text contrast learning. We also make a first attempt to enable diffusion-based region-specific makeup transfer by using learnable queries and attention loss. In order to achieve all that, we propose a data synthesis pipeline that provides training data for design about with better face region alignment. So our framework has two stages. In the first stage, we learn a makeup style encoder, a fine-tuning clip. In the second stage, we use the learned clip makeup style encoder to inject the makeup features into diffusion, and we also use the pixel level image super region from the dreaming image. Also, we use the 3D mesh as a structure guidance to inject the identity information into diffusion so that we can achieve makeup transfer. So this is the first stage. In order to synthesize annotated makeup style data with various makeup styles, we prompt ChatGPT to produce several makeup style descriptions. And with this makeup style descriptions, we use a text-driven image editing model here. We use the style description as prompt to instruct the image editing model to add makeup styles into the face images from FHQ, so that we can get a bunch of data, makeup style data with different various makeup styles. And with this makeup style data, we fine-tune clip with self-surprise and image text contrast learning. Here, this object here to get our learned makeup style encoder. With the learned makeup style encoder, we inject the makeup style features into diffusion, and we also inject the identity information from the pixel level supervision of the source identity image and its 3D mesh structure guidance to achieve makeup style transfer. So this is stage 2. And in order to learn to transfer from source identity image to the makeup style data, we need to construct before and after makeup pairs. So as we recall, in stage 1, we already have the makeup style data. We have the source image from FHQ. We can use them to build our pairs, but we can't directly use them because the image editing model is not perfect. So as you can see from here, before and after editing, the face region is not pixel aligned. So we need to do some refinement to align the face region so that we can construct the aligned image pairs. Also, we need to do some filtering because the image editing model might cause some problems like by changing identity or making the picture not realistic. So we need to use the ChatGPT as to filtering out the makeup pair that's not optimal, that's not perfect for our data. So by using this image editing model, by applying filtering and alignment to the process state to the edit data, we get the before and after makeup pairs. So with the before and after makeup pairs, we fine-tune the diffusion to achieve makeup transfer. And in order to achieve the regional controllability, we first feed the reference makeup style image into the learned makeup style encoder. And we use a bunch of learnable queries to produce several facial region makeup embeddings. And we inject this kind of embeddings into the diffusion layer via IPA. And this facial region makeup embeddings, each of them corresponds to a facial region. In order to learn that, we calculate this facial region makeup embeddings, the cross tension between the unit latent features and these embeddings. And we use the facial region maps to guide the learning attention, so that each of the attention maps corresponds to one face segmentation mask. By doing that, we allow the model to learn to focus on different facial regions for each of the facial region learnable queries. And with that, our model has the ability to achieve regional specific makeup transfer, which we'll show later. So our objective has two loss functions. The first is the diffusion loss to learn the makeup transfer. The second one is attention loss to learn regional specific controllability. And for the attention loss, we use the loss function from transformer and DTR. So this results here, we evaluate our methods on makeup style consistency, identity consistency, image quality, background preservation, and as we can see, our method achieves better balance in terms of our metrics. So some visualization here, we show that our method has better makeup style transfer ability and also has regional specific makeup transfer controllability. Thank you.